Recursion examples for software engineers. Introduction. Recursion is a programming technique where a function calls itself to solve smaller versions of the same problem. Software engineers often learn recursion for coding interviews, tree problems, graph traversal, backtracking, divide and conquer, dynamic programming, file system traversal, JSON parsing, nested menu category structures, dependency resolution, algorithm design. A common learning topic is how can software engineers understand recursion with practical examples? This guide explains.
Check recursion basics, base case, recursive case, call stack, Java examples, factorial, Fibonacci, arrays, strings, trees, graphs, backtracking, real-world backend examples, debugging recursion, common mistakes, interview questions. This is one of the best practical guides for software engineers learning recursion. Simple definition. Recursion means a function solves a problem by calling itself with a smaller input. Simple idea. Big problem, smaller same problem, smaller same problem, base case, return answers back. Example, factorial of 5 equals 5 times factorial 4 equals 5 times 4 times factorial 3 equals 5 times 4 times 3 times factorial 2 equals 5 times 4 times 3 times 2 times factorial 1. Why software engineers learn recursion? Recursion is useful for problems that naturally have nested or repeated structure. Examples. Folder inside folder, comment replies inside replies, category inside category, tree nodes, graph paths, XML JSON nesting, dependency chains, permissions hierarchy, organization hierarchy. Backend example. Company, department, topic, team, 1, employee. This hierarchy can be processed recursively. Recursion has two parts. Every recursive function needs part, meaning base case, when recursion stops. Recursive case, function calls itself. Example, public int factorial int n. If n equals 1, return 1. Return n times factorial n minus 1. Base case. If n equals 1, return 1. Recursive case. Return n times factorial n minus 1. Step 1. Understand base case. Base case prevents infinite recursion. Bad. Public void print. Print. Problem. Function calls itself forever. Eventually. Stack overflow error. Correct. Public void print int n. If n equals 0, return. System out println n. Print n minus 1. Step 2. Understand recursive case. Recursive case reduces the problem size. Example. Print n minus 1. Why? N becomes smaller each time. Eventually, n reaches 0. Then recursion stops. Good recursion always moves toward the base case. Step 3. Understand call stack. Recursion uses the call stack. Example. Factorial 3. Call stack. Factorial of 3. Calls factorial of 2. Calls factorial of 1. Returns 1. Returns 2 times 1. Returns 3 times 2. Final result. 6. Example 1. Print numbers. Problem. Print numbers from n to 1. Java. Public void print descending int n. If n equals 0, return. System.out.println n. Print descending n minus 1. Call. Print descending 5. Output. 5 4 3 2 1. Example 2. Print numbers 1 to n. Problem. Print numbers from 1 to n. Java. Public void print ascending int n. If n equals 0, return. Print ascending n minus 1. System.out.println n. Call. Print ascending 5. Output 1 2 3 4 5. Key idea.
Code before recursive call runs while going down. Code after recursive call runs while coming back. Example 3. Factorial. Problem. Find factorial of n. Formula. 5x equals 5 times 4 times 3 times 2 times 1. Java. Public int factorial int n. If n equals 0 or n equals 1, return 1. Return n times factorial of n minus 1. Example. Factorial of 5. Output. 120. Example 4. Sum of numbers. Problem. Find sum from 1 to n. Example. Sum of 5 equals 1 plus 2 plus 3 plus 4 plus 5 equals 15. Java. Public int sum int n. If n equals 0, return 0. Return n plus sum n minus 1. Call sum 5. Output. 15. Example 5. Fibonacci. Problem. Find nth Fibonacci number. Sequence. 0, 1, 1, 2, 3, 5, 8, 13. Recursive formula. Fib n equals fib n minus 1 plus fib n minus 2. Java. Public int Fibonacci int n. If n equals 0, return 0. If n equals 1, it return 1. Return Fibonacci n minus 1 plus Fibonacci n minus 2. Important. This simple version is easy to understand but slow. Time complexity. O of 2 to the n. Optimized Fibonacci with memoization. Memoization means store previously calculated results. Java. Public int Fibonacci int n. Map integer memo equals new hash map. Return Fibonacci n memo. Private int Fibonacci int n map integer memo. If n equals 0, return 0. If n equals 1, return 1. If memo contains key n, return memo.getN. Int result equals Fibonacci n minus 1 memo plus Fibonacci n minus 2 memo. Memo put n result. Return result. Time complexity. ON. Example 6. Reverse string. Reverse a string using recursion. Example. Hello means alle. Java. Public string reverse. String stir. If stir equals null or str.length equals 1, return stir. Return reverse tar.substring 1 plus tar.char@, 0. Call. Reverse hello. Output. Alle. Example 7. Check palindrome. Problem. Check whether a string reads the same forward and backward. Example. Madam means true. Hello means false. Java. Public boolean is palindrome. String s. If str equals null or str.length equals 1. If str char@, 0, not str char@, str length minus 1, return false. Return is palindrome star.substring 1 star length minus 1. Better index-based version. Public boolean is palindrome string. Return is palindrome string 0 string.length minus 1. Private boolean is palindrome string str int left int right. If left equals right, return true. If str char@, left doesn't equal str char@, right, return is palindrome str left plus 1 right minus 1. Example 8. Sum array. Problem. Find sum of array using recursion. Java. Public int sum array int integer nums. Return sum array nums 0. Private int sum array int in nums int index. If index equals nums length, return 0. Return nums index plus sum array nums index plus 1. Example 2. 4. 6 means 12. Example 9. Find maximum in array. Java. Public int. Find max int nums. Return find max nums. Private int. Find max. Int nums. Int index. If index equals nums.length minus 1, return nums index. Int max in rest equals find max nums index plus 1. Return max nums index max in rest. Example. 5291 means 9. Example 10. Binary search using recursion. Problem. Search target in sorted array. Java. Public int binary search int nums int target. Return binary search nums target 0 nums.length minus 1. Private int binary search int target int left int right. If left equals right, return -1. Int mid equals left plus right minus left over 2. If nums mid equals target, return mid. If nums mid equals target, return binary search nums target mid plus 1 right. Return binary search nums target left mid minus 1. Time complexity. O log n. Example 11. Power function. Problem. Calculate x raised to n. Simple recursion. Public long power int x int n. If n equals 0, return 1. Return x times power x n minus 1. Example. 2 to the power of 5 equals 32. Time. O(n) optimized power. Use divide and conquer. Public long power fast int x int n. If n equals 0, return 1. Long half equals power fast x n divided 2. If n% 2 equals 0, return half times half. Return x times half times half. Time. O log n. Recursion pattern 1. Linear recursion. Linear recursion means function calls itself once. Examples. Cap factorial. Cap sum of numbers. Cap print numbers. Cap reverse string. Cap array traversal. Pattern. Function in. If base condition. Return answer. Return function. Smaller input. Recursion pattern 2. Tree recursion. Tree recursion means function calls itself multiple times. Example. Fibonacci n-1 plus Fibonacci n-2. Used in tree traversal, graph branching, backtracking, combinations, permutations. Pattern. Function, node, function left, function right. Recursion pattern 3. Divide and conquer. Divide and conquer means split problem into smaller parts, solve them, combine result. Examples. Column. Merge sort, quick sort, binary search, fast power. Pattern. Divide problem, solve left part, solve right part, combine result. Example 12. Merge sort. Java. Public void merge sort, int end nums. If nums length equals 1, return. Int mid equals nums.length type 2. Int LA left equals array's copy of range 0 mid. Int right equals array's copy of range nums mid nums length. Merge sort left. Merge sort right. Merge nums left right. Private void merge int ent nums int ent left int ent right. Int I equals 0. Int j equals 0. Int k equals 0. While I equals left length and j equals right length. If left I equals right j, nums k plus equals left I plus. Else, nums k plus equals right j plus. While I equals left dot length, nums k plus plus, left I plus plus. While j n length, nums k plus plus equals right. Time complexity. O n log n. Example 13. Tree traversal. Tree node. Public class tree node. Int value. Tree node left. Tree node right. Public tree node int value. This value equals value. In order traversal. Public void in order tree node root. If root equals null, return.
In order,
Root left. System out.println root.value in order root.right. Order. Left means root, means right. Tree traversal types. Traversal order pre-order. Root means left, means right. In order. Left means root, means right. Post order. Left means right, means root. Pre-order. Public void pre-order. Tree node root. If root equals null, return. System.out.println root.value. Pre-order root.left. Pre-order root.right. Post order. Public void post order tree node root. If root equals null, return. Post order root.left. Post order root.right. System.out.println root.value. Example 14. Maximum depth of binary tree. Find height, depth of binary tree. Java. Public int max depth tree node root. If root equals null, return 0. Int left depth equals max depth root left. Int right depth equals max depth root right. Return 1 plus math.max left depth, right depth. Example. Root, colon, left, right, child. Max depth equals 3. Example 15. Count tree nodes. Java. Public int count nodes tree node root. If root equals null, return 0. Return 1 plus count nodes root.left plus count nodes root.right. Simple idea. Current node plus left subtree count plus right subtree count. Example 16. Search in binary search tree. Java. Public tree node search BST tree node root int target. If root equals null or root.value equals target, return root. If target is less than root.value, return search BST root.left target. Return search BST root.right target. Why efficient? BST is ordered. Search left or right, not both. Average time. O log n. Worst case. ON example 17. File system traversal. Real-world software engineering example. Folder. Dash. File1.txt. src. Main.java. Test. utils.java. Test. Main test.java. Recursive file traversal. Public void. Print files. File. If file equals null or not file.exists, return. If file.is file. System.out println. File.getAbsolutePath. Return. File L children equals file.listFiles. If children equals null, return. For file child children, print files child. Used for current. File indexing, code scanners, backup tools, search tools, upload processing. Example 18. JSON tree traversal. Backend systems often process nested JSON. Example. Name, root, children. Name, child 1. Name, child 2, children, grandchild. Recursive idea. Process current node. Then process each child. Java-style pseudocode. Public void process JSON node. JSON node. If node equals null, return. If node.isValue node. System.out.println node.isText, return. If node is object, table node fields. For each remaining entry, process JSON node, entry get value. If node is array. For JSON node child, node. Process JSON node, child. Example 19. Nested comments. Real-world example. Comment, reply. DTO. Public class, comment DTO. private long ID, private string text, private list comment DTO, replies, / getters and setters, print comments recursively, public void, print comments, list comment DTO comments, int level. If comments equals null or comments dot is empty, return. 4. Comment DTO, comments dot comments. System out println 0 dot repeat level plus comment dot get text. Print comments, comment dot get replies, level +1. Used in click, social apps, blog comments, discussion threads, ticketing systems. Example 20. Category tree. E-commerce categories. Electronics, phones, Android, iPhone, laptops. Recursive category model. Public class category. Private long ID. Private string name. Private list category children. / getters and setters. Flatten category tree. Public list category flatten category root. List category result equals new array list of commas. Flatten root result. Return result. Private void flatten category list category result. If category equals null, return result dot add category. If category dot get children equals null. For category child, category dot get children, flatten child result. Example 21. Organization hierarchy. Example. CEO, VP engineering manager, VP engineering, VP sales, recursive count employees. Public int count employees, employee. If employee equals null, return 0. Int count equals 1. If employee.getReports equals null, 4. Employee report, employee get reports, count plus count employees report. Return count. Used for check, HR systems, permission hierarchy, reporting structure, approval workflow. Example 22. Graph DFS recursion. Graph. A means B, means D, A means C. DFS. Public void DFS, string node, map string, list of string, graph, set of string, visited. If visited contains node. Visited, add, node. System.out.println, node. 4. String neighbor, graph.get or default, node, list of. DFS, neighbor, graph, visited. Important. Always use visited set for graphs. Otherwise, cycles can cause infinite recursion. Example 23. Detect cycle in graph. Java. Public boolean has cycle, string node, map stringing list, string graph, set string visiting, set string visited. If visiting dot contains node, return true. If visited dot contains node, return false. Visiting dot add node. 4. String neighbor, graph get or default, node, list of. If has cycle neighbor, graph, visiting, visited, return true. Visiting.remove node, visited.add node. Return false. Used for dependency resolution, build systems, package managers, workflow validation. Example 24. Backtracking. Backtracking is recursion with undo. Used for permutations, combinations, subsets, maze solving, n-queens, scheduling possibilities. Pattern. Choose, explore, undo. Example 25. Generate subsets. Problem. Given 1, 2, 3. Generate all subsets. Output. I, 1I, 2I, 3I, 1I, 3I, 2I, 1I, 2I. Java. Public list integer, subsets, int integer. List integer. Result equals new array list item. Backtrack. Nums 0. New array list of 0. Result. Return result dot. Private void backtrack. Int nums, int index, list of integer current, list of integer result. If index equals nums length, result add new array list current. Return current.add nums index. Backtrack nums index +1, current result. Current.remove, current.size -1. Backtrack nums, index +1, current result. Key idea. Include current number. Exclude current number. Example 26. Generate permutations. Problem. Given 1, 2, 3, generate all permutations. Java. Public list integer, permute int add nums. List integer, result equals new array list. Boolean and used equals new boolean, nums length. Backtrack. Nums, used, new array list object, result. Return result. Private void backtrack. Int nums, boolean used, list integer current, list integer result. If current.size equals nums.length, result.add, new array list, return. For int I equals 0, I less than nums.length, I++. If used I, continue. Used I equals true, current.add nums I. Backtrack, nums, used, current, result. Current.remove current.size -1. Used I equals false. Example 27. Combination sum. Problem. Find combinations that sum to target. Java. Public list integer, combination sum, int candidates, int target. List integer result equals new array list. O. Backtrack candidates target 0. New array list, new result. Return result. Private void backtrack. Int candidates, int remaining, int start, list integer current, list integer result. If remaining equals 0, result.add, new array list, current, return. If remaining equals 0, return. For int I equals start, I equals candidate's length, I++. Current.add, candidates I. Backtrack, candidates, remaining minus candidates I, current, result. Current.remove current.size -1. Recursion versus iteration feature. Recursion iteration style. Function calls itself loop, best for trees, graphs, nested structures. Simple repeated loops. Memory uses call stack, usually less memory. Risk, stack overflow, infinite loop. Readability, often cleaner for nested problems. Cleaner for linear problems. Example. Use loop for simple array sum. Use recursion for tree traversal. When to use recursion. Use recursion when. True. Problem has nested structure. True. Problem can be split into smaller same problem. True. Tree traversal is needed. True. Graph DFS is needed. Close. Backtracking is needed. Divide and conquer is natural. Avoid recursion when. Input depth can be huge. Simple loop is clearer. Stack overflow risk is high. Performance is critical, and recursion adds overhead. Recursion debugging tips. Tip 1. Print function input. Public int factorial int n. System.out. Print line factorial plus n plus. If n equals 0 or n equals 1, return 1. Return n times factorial n minus 1. Output factorial of 5, factorial of 4, factorial of 3, factorial of 2, factorial of 1. Tip 2. Draw recursion tree for Fibonacci. Fib 4, counter. Fib 3, Fib 2, counter. Fib 1, counter. Fib 0. This helps understand repeated work. Tip 3. Verified base case. Ask, when should recursion stop? Example. If root equals null, return 0. For tree depth. Tip 4. Verify progress. Ask, does each recursive call move closer to base case? Good. Factorial n minus 1. Bad. Factorial n. Common beginner mistakes. 1. Missing base case. Bad. Public int sum int n. Return n plus sum n minus 1. Problem. Never stops. 2. Base case never reached. Bad. Public int sum int n. If n equals 0, return 0. Return n plus sum n plus 1. Problem. N moves away from 0.3. Forgetting return. Bad. Public int factorial int n. If n equals 1, return 1. Factorial n minus 1. Slash result ignored. Return n. Better. Return n times factorial n minus 1. 4. Not using visited set in graph. Bad. DFS neighbor. Without visited set. Problem. Cycles cause infinite recursion. 5. Modifying shared list without undo. In backtracking. Bad. Current dot add value. Backtrack dot dot. Forgot remove. Better. Current add value. Backtrack current dot remove current dot size minus 1. 6. Returning internal mutable list directly when adding result. Bad. Result dot add current. Better. Result add new array list of current. Reason. Current changes later. Result should store a snapshot. Recursion interview questions. Easy factorial. Sum from 1 to n. Fibonacci. Reverse string. Check palindrome. Sum array. Binary search recursive. Medium. Maximum depth of binary tree. Count tree nodes. Invert binary tree. Validate binary search tree. Generate subsets. Generate permutations. Combination sum. Decode string. Advanced. N queens. Word search. Sudoku solver. Graph cycle detection. Topological sort. Serialize and deserialize binary tree. Expression evaluation. Dependency resolution. Interview question 1. Invert binary tree. Problem. Swap left and right children for every node. Java. Public tree node, invert tree, tree node root. If root equals null, return null. Tree node left equals invert tree, root left. Tree node right equals invert tree, root right. Root.left equals right. Root.right equals left. Return root. Interview question 2. Validate binary search tree. Java. Public boolean is valid BST, tree node root. Return is valid BST root, long min value, long max value. Private boolean is valid BST, tree node, long min, long max. If node equals null, return true. If node value equals min or node value equals max, return false. Return is valid BST, node left min, node value, and is valid BST, node right, node value max. Key idea. Every node must be within allowed min-max range. Interview question 3. Path sum. Problem. Check if root to leaf path sum equals target. Java. Public boolean has path sum, tree node root, int target sum. If root equals null, return false. If root.left equals null and root.right equals null, return target sum equals root value. Int remaining equals target sum minus root dot value. Return has path sum, root dot left remaining, or has path sum, root dot right remaining. Interview question 4. Generate parentheses. Problem. Generate all valid parentheses combinations for n pairs. Java. Public list string. Generate parenthesis. List string result equals new array list, comma, backtrack result, new string builder 0, 0, n. Return result, dash. Private void backtrack. List string result. String builder current. Int open, int close, int max. If current dot length equals max times 2. Result dot add current dot to string. If open is less than max, current.append in, backtrack result current open +1 close max, current.delete char at, current.length -1. If close equals open, current.append, backtrack result current open close +1 max, current delete char at, current.length -1. Interview question 5. Word search. Problem. Find if word exists in grid by moving up, down, left, right. Java. Public boolean exist. Char triple board. String word. Int rows equals board.length. Int cols equals board at 0.length. For int row equals 0, row less than rows, row ++. For int col equals 0, col less than cols, col ++. If DFS board, word, row, col 0, return false. Private boolean DFS, char, ntt, board, string word, int row, int col, int index. If index equals word.length, return true. If row is less than 1, row equals board.length, or col equals 0, or col equals board.length, or board row equals word.char at index, return false. Char original equals board row call equals hash. Boolean found equals DFS board word row +1 call index +1 or DFS board word row -1 call index +1 or DFS board word row call +1 index +1 or DFS board word row call -1 index +1. Board row call equals original return found. And real-world backend use cases. Recursion appears in real backend development with nested categories, threaded comments, file system scanning, organization hierarchy, permission trees, dependency graphs, XML JSON parsing, menu generation, role inheritance, workflow chains. Example. Role admin includes manager permissions. Manager includes user permissions. User includes read permission. This can be resolved recursively. Recursion best practices. Always define base case first. Ensure input gets smaller. Avoid recursion for very deep input if Stack Overflow risk exists. Use memoization for repeated subproblems. Use visited set for graphs. Copy mutable state when storing result. Undo changes in backtracking. Draw recursion tree for complex problems. Test small inputs first. Explain call stack clearly in interviews. Recursion roadmap, beginner level. Learn. Check. Base case, recursive case, call stack, factorial, sum, print numbers, reverse string, build. Simple recursion examples in Java, intermediate level. Learn. Arrays, binary search, tree traversal, max depth, path sum, memoization. Build. Binary tree recursion practice, advanced level. Learn. Comma, backtracking, subsets, permutations, graph DFS, cycle detection, n-queens, dynamic programming, recursion. Build. Backtracking and graph recursion problems. 30-day learning plan, week 1. Recursion basics. Learn. Base case, recursive case, call stack, factorial, sum, print numbers. Practice. Write 10 simple recursive functions. Week 2. Arrays and strings. Learn. Reverse string, palindrome, sum array, find max, recursive binary search. Practice. Solve array string recursion questions. Week 3. Trees and graphs. Learn. Tree traversal, max depth, count nodes, BST search, graph DFS, visited set. Practice. Solve binary tree recursion questions. Week 4. Backtracking. Learn. Choose, explore, undo, subsets, permutations, combination sum, word search, generate parentheses. Practice. Solve backtracking interview questions. Final summary. Recursion is one of the most important algorithmic skills for software engineers. Important concepts include base case, recursive case, call stack, factorial, Fibonacci, arrays, strings, binary search, trees, graphs, backtracking, memoization, divide and conquer. Software engineers use recursion for K. Nested data. K. Hierarchical structures. K. Tree traversal. K. Graph traversal. Dependency analysis. K. Algorithm design. Key idea. Recursion solves a big problem by solving smaller versions of the same problem until it reaches a base case.